CPU scheduling is a confirmed area from where always questions are coming, and unfortunately and fortunately students are doing mistake here. Students are getting confused here because in the numerical they are doing mistake. So that's why I am here for you to make this topic more easy, and after watching this video, all the algorithm, all the CPU scheduling numerical will be very easy for you and you will get the score here. So definitely watch this video till the end and we will solve the numerical. I will give you the tricks also. I will tell you each and every point that where you can do the mistake. Why, where the students are doing mistake. Especially problem is happening on round robin algorithm. So I will teach you round robin algorithm also in easy way so that you will never forget. So that's why definitely watch the video till the end and subscribe to the channel. Click the bell icon to get all the latest update and notification. Please like this video if you like and please share this video to all of your friends. So let's start. And after completion, I will come to the last minute revision so that it will be clear for you. So let's start with the Fcfs, that is called the first come first serve. So let me change the color of my pen. Here I think black color will be better. Yes. So first thing is that Fcfs, that is first come first serve. Who will come first? They will serve first. Right? This is called first come first serve. So by learning this, it is most of the students are thinking that it is very easy. Who will come first? I will take that first. But here the problem are happening. So I am telling you some common area where the students are doing mistake. First common area is to know all the CPU algorithm, all the CPU scheduling algorithm. Some terminologies are required. First of all, AT, that is called arrival time. Arrival time. So always, whatever algorithm it is, if it is Fcfs, SJF, round robin, always check the arrival time. Because whatever constraint is there, if it is not arrived, you cannot do anything with that process. Because CPU scheduling means when the process are coming and they are trying to execute, now CPU will allocate the slots to them, right? So if any process is not arrived yet, then what CPU will do? So that's why always be careful about the arrival time. Here so many students are doing mistake. Now after arrival time, next thing is the burst time. So burst time means here it is called the when how much time is required to execute the process. That is called the burst time. Burst time means how much time is required to execute. Think like that you are coming to doctor. There is a long queue in the doctor. You also came there. Other patients are also there. So when each and every patient arrived to that hospital, that is the arrival time of that patient. Now, actually, doctor is taking how long time? Doctor is taking you only 5 minutes, 10 minutes maximum. That checkup time is your burst time. Now, there is the completion time. Completion time means when you ultimately coming out from the hospital. All the everything is done, payment is done, your waiting time is also there. You are taking the medicine and all, everything is done, and after that you are coming out from the hospital. That is your completion time. When your total things is completed. Completion time. Right? Now, after completion time, here is a turnaround time. Now, what is turnaround time? Turnaround time means here completion time means maybe you went to hospital at 10 a.m. and ultimately you complete all the work in hospital at 2 p.m. like that, or 12 p.m. like that, or 1 p.m. whatever it is. So that is your completion time. So here I am taking that you came to hospital, arrival time is 10 a.m. Burst time, doctor checkup and your test and all, taking medicine, that is only I am taking 1 hour maximum. All this but your completion time is here maybe 1 p.m. maybe 1 p.m. So here your turnaround time, what will be the turnaround time? Turnaround time will be completion time minus arrival time. So when you complete your task, that is 1 p.m. and you arrive at 10 a.m. So 10, 11, 12, 1. 3 hours is your turnaround time. Now next one is the waiting time. Waiting means how long you are waiting. Actually, you are sitting in a place and you are waiting. Nothing is going on. No testing, no checkup, no for medicine, anything. Anything, nothing is going on. Just you are waiting in a sitting on a chair or you are scrolling mobile. That is a waiting time, right? So what is the waiting time here? Waiting time is turnaround time minus burst time. So ultimately, this was means when you arrive and when you completed the task, that was your 3 hours is your turnaround time, and your waiting time is from that 3 hours. Actual checkup time was 1 hour. So this 2 hour is your waiting time, right? This 2 hour is your waiting time. So I hope now these all are clear. And response time. Then another concept is coming, that is response time. Response time means when process getting chance, one means getting chance in the CPU. When it is getting chance in the CPU, that is the response time. Means it is like that. You arrived at 10 a.m. and maybe 10:15 a.m. Maybe 10:15 a.m. your fast call. Normally it is happening when we are going for the eyes checkup. So your fast call is there. Okay, they will call you and they will check your are you able to see that, and or power, that power checkup, optometrists are checking the power checkup is done. That was your first call, and after that they put the medicine. Now again wait, and that waiting time is a too long waiting time, right? So that 10:15 a.m. was your first call. It is not completed. Fast checking, or maybe your pressure check, your temperature check is done. That is this is your response time when process gets the CPU for the first time. Okay, minus the arrival time. Minus the arrival time when you arrive. Okay, so this is your response time. That is the concept when it is getting the first chance. That is called the response time. Got it? Now I am coming to the concept one by one. It will be required for mainly when we will go for the primitive algorithm. There are two types. There are two types. One is primitive scheduling, another is non-primitive scheduling. What is primitive? Primitive means preemption, means before completion of the work. Preemption means here FCFS we will do in the next page. So here we are not doing FCFS. Here I am telling the CPU scheduling is divided into two parts. One is called preemption, preemptive, another is non-preemptive. Okay, so preemptive and non-preemptive difference is that preemptive means before completion of the work, means total for my checkup, for my doctor checkup, total time is 1 hour. Actually, total time will be 1 hour. And if I am not completed in that time, anyone cannot come. Maybe I am thinking like that. But here it is what it is going on. 10 minutes you are getting chance. After that again you are waiting. Again 10 minutes another one is getting chance. Again after half an hour or 1 hour you are getting chance again. That is called the preemption. You have not completed your task, but some of the part is done. Again you are going to the waiting phase. Again you are waiting. Another one is getting chance. And finally again you are coming. This is called the preemption method. Before completion of the task of a process, it can be preempted so that another one can get the chance. And no preemption means when I am getting the chance. If it is my chance, if it is my turn, I will complete all my work. After that only another will get the chance. That is called no preemption. So if my time is required 1 hour, my full checkup will be done in 1 hour. After that, next patient will come. That is called the no preemption method. I hope preemption and no preemption is clear to you. Now I am coming to the Fcfs algorithm. And Fcfs algorithm is Fcfs is the first come first serve algorithm. Here first come first serve means what? That here I am taking an example. From the example it will be clear. See that. And all of you after giving try to do by yourself. Okay. So there is the process number. There is arrival time and the burst time. It will be given to you. So process number 1 arrival time 0 burst time 4. Process number 2 arrival time 1 burst time 3. Process number 3 arrival time 2 burst time 1. Process number 4 arrival time 3 and burst time 2. And process number 5 arrival time 4 and burst time 5. Okay. So here it is very easy. Here there is no problem in the arrival time or the burst time because who is arriving first, it will get the chance. So process number 1 will arrive first. Here we will prepare a NAT chart. This is called the NAT chart. This NAT chart will be prepared like that. It is always started with 0. When it is arrived at arrival time 0, who arrived? Process 1 arrived. So I will take process 1. And from process 1, it is a no premission. Here is not a premission, non-primitive algorithm. This is a non-primitive. This is a non-preemptive algorithm. Okay. Whenever it is getting chance, it will complete the task. So P1, after that 4, it will complete the task 4. At the 4 means 4 p.m. maybe you are thinking. After that, who arrived here? 1. He arrived already in 1 p.m. He arrived already in 1 p.m. but now he is getting chance at 4 p.m. So P2 get the chance. P2 will be execute till 7 because 4 plus 3 is 7. After that, P3 will get the chance. P3 only 1, so it will be 8. After that, P4 will get the chance and P4 will get what? That after 8 there is 10. It will be 10 and then P5 will get the chance, then it will be 15. So that is done, right? Now after doing that, you have to fill this table. How to fill the table? Here you have to fill the completion time, after that waiting time, after that turnaround time, then waiting time, and finally response time. Okay, so completion time always go from this side. That is better. Always going from back side. So completion time of P5 is 15. Just put it here 15. Completion time of P4 is 10 and here it is 8. Here it is 7. Here it is 4. This is my completion time. And what is turnaround time? Turnaround time was completion time minus arrival time. That was equals to turnaround time. So completion time is 4. Arrival time was 0. So here turnaround time is 4. Completion time is 7. 7 p.m. it is completing. Its checkup is done at 7 p.m. but it came at 1 p.m. So here turnaround time is 6 hours. Here it is completion time is 8 p.m. It came at 2 p.m. So here also 6 hours. 10 p.m. it came at 3 p.m. Here it is 7 hours. Here 15 and 4 p.m. So it will be 11 hours, right? That is the turnaround time. Now what is waiting time? Waiting time is turnaround time minus burst time. That was waiting time. So how much I am waiting? That is the turnaround time 4 and burst time was also 4. Turnaround time minus burst time. So turnaround time is also 4, burst time is also 4, waiting time is 0. Turnaround time is 6, burst time is 3. So waiting time will be 3. Turnaround is 6, burst time is 1. So it will be 5. Turnaround is 7, burst time is 2. So it will be 5. Turnaround 11, burst is 5. So it will be 6. So these are the waiting time 0, 3, 5, 5 and 6. And what is the response time? Here actually for Fcfs and for all non-primitive algorithm, your response time will be also same. It will be also same as the waiting time, because ultimately when I am getting chance, I am completing my task. So how long it is taking response, that will be same. Here it will be same. So response time was that when CPU get the chance, when P1 get the chance at 4, and when it is arrived at 0. So that's why 4 minus 0 will be here. That is, I am 4 minus 0 will be, means I am getting chance 4, I am arriving at 0. That will be 4 only, the 0, right? That is the 0 only. So there is no problem here when I am getting the P1 is coming at time 0, arrive at time 0 and getting the chance at 0 also. So that's why response time is 0. And when P2 get chance at 4 but arrive at 1. So what is the response time? Response time is 3. When it is getting chance on CPU first time getting chance on CPU minus the arrival time, that is we are getting, right? So it is getting chance at 7, but when it arrive at 5. So that's why it will be 5. It was 5, that is 7 minus 2, arrive at 2. Here it is the 8 and arrive at 3. So 8 minus 3 will be 5 again. Here it's getting chance at 10 and arrive at 4. So it will be 6. So here you can see one thing. The waiting time and response time is same here. Why? Because it is a no preemption method. As there is no preemption, so response time and waiting time will be same. If it is preempted, then waiting time can be more. Before means I am getting for the 10 minute, I am getting chance for the 10 minutes, still my 40 minute is remaining, but I am waiting for 2 hours. Then waiting time will be increased, but response time will be different for the preemption method. So I hope this concept is clear now, right? Okay. Now I am going to the SJF and I am focusing on that. You are doing the last night study here and you are trying to complete this chapter. So that's why I am recording in one shot, one video only. So SJF is called shortest job first. Shortest job first. Right? Shortest job first. Who is shortest job? He will get the chance. It will get the chance. Right? So here I am taking example P number. After that arrival time. Then burst time. So process number is 1, arrival time 1, burst time 7. Process number 2, arrival time 2, burst time 5. Process number 3, arrival time 3, burst time 1. Sorry, it is 1. Let me erase this. So after 5, this is 1. Okay. Then next one is 4, then 4, then 2, and here it is 5, then 5, then 8. Now try to do it. I will suggest you, please try to do it by yourself. SJF, who is the shortest one, it will get the chance. And do it. Do that, the NAT chart. Who will get the chance? Without watching, please let me know in the comment section. That's why I want to see that how many of you are doing correct and how many of you are doing wrong. Before going to the next, only comment in the comment section. Who will get the chance? Okay, and don't erase your comment after knowing the correct answer. Okay. So who will get the chance? Who will get the chance? Most of the students will think that yes, here my burst time is minimum 1. So that's why P3 will get the chance. But that is wrong. Because what? Because we have to check always the arrival time. The arrival time is a most important factor here. So at the time 0, anyone arrived? Anyone not arrived at time 0? Who at time 1 someone arrived? So here it will be idle. This time no one is working. After that, when at 1, in this time 1, who arrived? Only P1 arrived. Although the burst time is 7, but no one arrived. So what the CPU will do? As that it is, so maybe that patient will take 7 hours, but that patient only arrived. So definitely I have to get the chance, right? So that's why here P1 will get the chance. And this is SJF is a non-preemptive. Here no preemption. You cannot preempt. Another version of SJF is there, that is where the preemption is going on, but this is no preemption, no preemptive. Another version of SJF, that is I am coming to later, that is SRTF, shortest remaining fast, or preemptive shortest job fast. In that way they are giving. So here whenever it is getting chance, it will complete its tasks till 8. Now at 8 p.m. Now time is 8 p.m. In that time, see that who arrived? Everyone arrived. It arrived at 2 p.m. It's arrived at 3 p.m. It's arrived at 4 p.m. And it's arrived at 5 p.m. Now out of all them, I will take the shortest one. Now this is my shortest one. Now P3 will get the chance, and I hope now it is clear to you. Most of the time students are doing mistake here. So P3 is now 9 because it is the 1. After that, who is the shortest one? After this one, shortest one is P4. So P4 will get the chance. P4 will execute till 11. After, next one is P2. P2 will get the chance. It is 5 means it will be 16. And after P2 will get the chance. Who is there? P5. Next, last one. That is P5. P5 is 8. So it will be till 24. I hope this is clear to you. Now the next task is to do the completion time, waiting time and turnaround time. So just do it quickly. What is completion time? What is turnaround time? And what is waiting time? Completion time, again go from this side. When you are going for this side, that is 24. Who is 24? P5 is 24. So put here P5 is 24. P5 not, sorry, it is 24. And here it is 16. Who is 16? P2 is 16. So P2 is 16. Here it is 11. Who is 11? P4 is 11. Put here 11. 9. Who is 11? 9. P3 is 9. And here 1. Who 8? Who is 8? P1 is 8. So in that way fill it so that there will be no mistake. Okay. So we got here 24, 16 and all. Fill this. After that turnaround time was completion time minus arrival time. So here completion time is 8, arrival time is 1, 8 minus 1 is 7, 16 minus 2 that is 14, 9 minus 3 that is 6, 11 minus 4 that will be 7 and 24 minus 5 that will be 19. That is our turnaround time. What will be the waiting time? Waiting time is turnaround time minus burst time. 7 minus 7 that is 0. 14 minus 5 that will be 9. 5, 6 minus 1 that will be 5. 7 minus 2, 5. 19 minus 8 that is 11. Okay. Now here last one, I forgot one thing, that here we have to calculate the total turnaround time and waiting time. They are asking that average turnaround time and average waiting time. So what will be the average turnaround time here? Here your average turnaround time means just do the total, all the total, and after that divide by how many processes are there. There is 1, 2, 3, 4, 5 processes. After that divide it, your average time will be here 6.8, and here average waiting time is add all, after that divide by 5. So here it will be your 3.8. Okay, so that they are asking you what will be the average waiting time, what will be the average turnaround time, and sometimes they are asking that what is the waiting time for this process. That is also they are asking what is the turnaround time for this process. Partially also they can ask. And here after doing your average turnaround time will be average turnaround time, just calculate all, add all. After adding, this will be actually 53. If you are dividing 53 divide by how many process, 5 process, 53 divide by 5, you will get here 10.6. And average waiting time, here total waiting time will be 30. So 30 divide by 5, it will be 6. That is the answer for the SJF, shortest job fast. So this is clear, and now you will not do any mistake in shortest job fast, right? Now the next one we are doing, that is shortest remaining, SRTF. SRTF. It is the primitive version of SJF. It is the primitive version of SJF. Sometimes they are giving the name SRTF, shortest remaining time fast. The name is shortest remaining time fast, or it is the primitive of SJF, right? So here I am giving a example. Take an example and we will do that from that example. P number, arrival time and burst time. So here it is 107, then 213, 215, sorry. Very sorry. Just so here it is 215. After that 323, and after that 431, then 542, and finally 6, 5 and 1. This is the process number, arrival time and burst time. Okay. Now in shortest remaining time fast means it will check in every millisecond. In every millisecond means every unit of time, not millisecond, every unit of time it will check. What is the remaining task? What is the remaining task? Who is the shortest one? So here how the NAT chart will be, just check the NAT chart here. Your NAT chart will be like this way. So here it is time 0, and always arrival time. Always we will work on arrival time. Arrival time 0, only P1 arrived. So definitely P1 will get the chance. There is no other one. P1 will get the chance, and it will work 1 unit. 1 unit, that is it will work till 1. Now here it is remaining 6. At that time who arrived? At that time only P2 arrived. No other one arrived. So P2 will get the chance here. P2 will get the chance. And after that, P2 will also work 1 unit of time. That is 2. And here it is remaining 4. Right? Now, after that, at that time, who arrived? P3 arrived. And see here, it is remaining 6, it is remaining 4, and it is 3. So that's why P3 will get the chance, and P3 will be till 3. Now it is remaining 2. Okay. Now who arrived? Now P4 arrived. So when P4 arrived, P4 is also remaining time only 1. So P4 will get the chance, and P4 will do 1 unit of time, that is 4. And now this is 0. At that time who arrived? At that time P5 arrived, and P5 is also 2. Now here is a tie. This is also 2 and this is also 2. Now who will get the chance? In this situation, according to the process number, we will break the tie according to the process number. So here P3, not P5. Here who will get the chance? P3 will get the chance, and the arrival time is also there. The arrival time was also 2. So here P3, P5 both are 2. Okay. And according to the arrival time, that is not only process time, according to the arrival time of the P3 is, means P3 came fast. So that's why P3 will get the time first. Got it? So now P3 will get the chance and P3 will execute till again 5. Now P3 is 1. Now out of all, P3 is only at that time already P6 also arrived. It is also 1, it is also 1. Again the tie. But who will get the chance? P3 will get the chance because arrival time is here. It arrived previously. So that's why again P3 will get the chance. It will be 6. Now this is 0. And now at that time, who is remaining? P6, that is the lowest one. So P6 will get the chance. It will be 7. And now this is 0. And now out of that it is 6, 4 and this is 2. So now P5 will get the chance. P5 will get the chance. And directly now you can execute till 9 because all whatever process queue was there, everyone already get the chance. Everyone for the first time get the chance. Now directly you can do because ultimately this will complete. Because if you see that it is 2 remaining, it is 4, it is 6. So already I can directly do it. P5 will do till 9. After that P2 will get the chance and P2 will do till 13. And after that P1 will get the chance. 12 will complete like till 19. And this is your SRTF, shortest remaining time first. And after that same way you will complete the completion time, turnaround time and burst time. And as we cut this, so that's why I am writing again the burst time. Original burst time was here 7, 5, 3, 1, 2, 0. That was my original burst time. And here now completion time. What is the completion time? Go from this side. P1 complete at 19. So put here 19. P3, P2 complete at 13. Put here 13. P5 complete at 9. So in P5 put 9. P6 completed at 7. So it is 7. Now again P3. So P3 is here. P3 is completed at 6. So put here 6. Here it is P3. So P3 already done. Here it is P4. P4 completed at 4. So put here 4. So our completion time is coming 19, 13, 6, 4, 9, 7. Now what will be the turnaround time? What is the turnaround time? Turnaround time will be my completion time minus arrival time. 19 minus 0. 19 minus 0 is 19. 13 minus 1, that is 12. Same way you have to do. That will be here 4, 1, 5 and 2. That is our turnaround. Next one is waiting time. Waiting time, turnaround time minus burst time. 19 minus 7, that is 12. 12 minus 5, that is 7. 4 minus 3, that is 1. And same way this will be 0. After that this will be 3 and this will be 1. Right? Yes. So here next one is, so here burst time was, sorry, here some again we did, that is the 1. Here this was burst time was not 0, that was 1. Right? So that's why 2 minus 1 is 1. Right? Now here, what is the response time? See, as it is the primitive, now response time and waiting time will be different. Previously you saw in the Fcfs, response time and waiting time was same. But here response time and waiting time will be different. Why? Because see, P1 get chance at 0 when P1 arrived at time 0. So 0 minus 0, we are doing here 0. P2 get first time chance at 1 and it arrive also 1. So 1 minus 1 is 0. P3 got chance first time at 2 p.m. It arrive also 2 p.m. So that's why it is again 0. P3 get chance, P3 already we did it, P3. P4 get the chance at 3 p.m. and arrive also 3 p.m. So it is also 0. P4 is done. So for the P4, after that P3, then again P3, then after that who get the chance here? P5 get the chance at 7. See that. First time when P5 get the chance, P5 get the chance here at 7 p.m. And when P5 arrive at 4 p.m. So what is the response time? First time I am getting chance at 7 p.m. and I arrive at 4 p.m. So my response time is 3. And finally for P6 get the chance at 6 p.m. and it arrive at 5 p.m. So that's why response time is 1. Now you can see the waiting time and response time is not same. So response time is, I hope it is more clear now. Whenever CPU is getting chance for the first time, minus the arrival time. But waiting time is total time, how long you are there from the waiting time. That was the turnaround time minus arrival time, minus the burst time. That was our waiting time, right? So our waiting time was turnaround time minus burst time. But the response time is when when the process get the chance first time, that is there minus the arrival time, that is called the response time. Got it? So I hope SRTF is clear to you now. Okay. So I hope everything is clear. Now we are going to the round robin algorithm. Here students are doing mistake most of the time, and after watching there it will be also very clear to you. Round robin scheduling is what? Round robin is working on time quantum. Here is a time quantum. What is time quantum? It is fixing some amount of time that it is also a primitive. It is also a primitive version, but in SJF it was going on, it was going on like that every time whenever every unit of time we are checking how much remaining, but here we will check according to the time quantum. If your time quantum is finished, then you have to come. And here main thing is, here we have to maintain two. One is process queue and another is nacture. How to do it? See that. Here I am taking time quantum is 2. Okay. And I am taking an example. So from that example, your round robin will be also clear. That is process number. After that, arrival time. Sorry. Mistake when writing. That is the arrival time. After that, one is my first time. Okay, so this is my birth. And here we will maintain 2q. How to maintain 2q? Here we are maintaining the process queue. One is process queue and another is the nacture. So process queue means what? Here I am writing first 104 and it was 215. Next one is 322. One is 4, 3 and 1. Next one is 5, 4 and 6. Next one is 6, 6 and 3. Okay. So from here, process Q means first one who arrived at the time. If I am going for the NAT chart, this is my NAT chart like this. Okay, this is our NAT. The NAT chart at the time 0. Who arrived? Only P1 arrived. So in the process Q also we are writing P1. Okay. So from P1 I will get only P1. Okay. And now P1 will execute maximum 2 quantum. Maximum 2 unit of time it can execute. So here burst time was 4. So it will execute till 2. And now it is 2 millisecond is remaining. Now when it is coming out at 2 p.m. I am coming out 2 p.m. When it is coming out at that time who arrived? Be careful here. When it is coming out at that time who arrived? You have to check that. And let me a little bit making good it. I am very sorry for handwriting. Very sorry for that. Little bit, but I hope your concept. So here, when I am coming out, 2 p.m. I am coming out. I did not complete my task. 2 p.m. I am coming out. At that time, who arrived? P2 and P3 arrived. So that's why in the process queue, I will write down P2, P1 already done. After that, P2, then P3. And now I did not complete my task. Till now, I need more 2. So that's why after that again you have to write P1. This is very important here. You have to understand this part very carefully. Very carefully. I am getting chance at arrival time 0. As my arrival time was 0 P1. So it get the chance. And it is executing 2 millisecond. Your time quantum was 2 milliseconds. So it is executing. And when it is coming out, that is 2 p.m. Now time is 2 p.m. So now who arrived? Who arrived? Already P2 and P3 arrived. That's why write down here P2 and P3. And as P1 not completed, till now P1 needs. So that's why now write down P1. And now who will be the next? That next one you have to check from the process queue. Don't go for here. Here if you are going, then you will do the mistake. You have to check from the process queue. In process queue, who is there? P2 is there. I will give the chance to P2. P2 will execute more 2 millisecond and its burst time is 5. And always checking the burst time. If it is like that, burst time is less than time quantum, then that is only. So if it is less than 2 millisecond, then I will execute that much only. Necessarily, I will not take the time, right? So that's why always check the burst time. Here it is 5. Now it will execute more 2 millisecond, that is 4. So here it will be remaining 3. Right? Now time is 4 p.m. Time is 4 p.m. At that time, who arrived? P2 already done this part. Always cross it. Otherwise, again you will do the mistake. So time is 4 p.m. At that time, who arrived? Already P4 arrived and P5 also arrived. Arrival time. Check that. So write down here P4 and then P5. P4, P5. Now, till now, P3, P2 did not complete its task. P2 till now remaining. Then after that, write down P2. Clear? I hope this is clear to you. So P3, after that P1, then P4, then P5, then P2. Done. Now again, who will get the chance? Check the process queue. Who is there? P3. So P3 I will take here, right? P3 will execute how long? P3 burst time is 2. So P3 will execute 2 millisecond, means it is 6 now, and this is now 0. P3 completed its task. At that time, who arrived? At that time, only P6 arrived. So write down here P6. And is it required to write P3 again here? Is it required to write P3 again here? No, because P3 already completed its task. P3 required 2 milliseconds and it is already completed the task. So that's why it is not required here. Now who will be my next one? My next one I will check from the process queue. No, not from here. I will check from here. P1. So I am taking this P1 here. P1 how long remaining? 2. So that's why P1 and time quantum is 2 also. So it will be 8. Now this is 0. And finally, after that next one, who is the, so see that already my all the process are here. No one is remaining. Is it required to repeat P1? No, not required. Because P1 already completed. Whenever it will be 0, means it is completed the task. So no need to repeat again, no need to write down again. Got it. Now here what it will be? After that who will come? P4. Take P4 here. Whenever you are taking P4, then check that the burst time for P4 was only 1. So it will execute till 9. Although the time quantum is 2. But I will not execute 2 because it is not required. I need only 1 millisecond. So my task is only 1. So I will do only 1. And after that it will be 0. Now is it required to P4 again? No, because P4 done its task. Problem. Now the next one is P5. P5 is getting the chance. When P5 got the chance, P5 remaining, it's required 6. But it cannot execute because time quantum is 2. So it will be till 11 it will execute and here it will be remaining 4. Now P5 is remaining. So that's why here again write down P5 because P5 did not complete its task. Whenever I am not getting 0 means till now it is remaining. So that's why I have to write down again. Got it? Now who is the next one? Next one is P2. Take P2 here. Whenever you are taking P2, at that time check here. For the P2 it's required 3. But we cannot allocate 3. We can allocate maximum 2. So that's why P2 will be now 13. Here till now it is remaining 1. So means I have to repeat again P2. Means write down P2 again here. Who is the next one? Next one is P6. Take the P6 here. Whenever you are taking P6, check that how much required 3. I cannot allocate 3. I can allocate maximum 2. That is, it will be till 15 and still 1 remaining. So means I have to repeat here again P6. Right? Now who is coming? Now P5. P5 came here. P5 is still now it is 4 remaining. I cannot allocate you 4. I have only 2. So that's why I can give you till 17. Till now it is 2 remaining. So that's why again you have to repeat here P5. After that who will come? P2. So I will give the chance to P2. When P2 is coming, now check. For the P2 it is only remaining 1. So it will be execute till 18 and now this is 0. It is executing till 18. Now this is 0. Okay. So after that, after P2, who is coming and is it required to repeat P2 now? No, because P2 I got 0. No need to recoup. Now the P6. So again, here I am taking the P6 now. P6 is remaining only 1. So I will give it till 19. Now P6 is coming 0. And finally P5. I will take the P5. P5 is now remaining 2. So that's why it will be 21. And that is now done. Now this is done. And I hope now it is very clear to you how to do the round robin algorithm. Right? Now how to write down the completion time. as the space is not there, little bit space problem is here, so I am writing the completion time in this side. Okay, you can write in the same way, you can follow the same way. So as there is the space problem, so I am writing the completion time here. Okay, and please write the original burst time here. Whenever you are writing the burst time, write the original burst time 4 5 2 1 6 3. Okay, so here what is the completion time? Completion time for P5 is 21. So P5, that is 21, P6, that is 19, and P2, that is 18, then P5, that is 17. P5 is already done. Sorry, P5 is already done. P6 is also done. P2 is also done. P5 is also done. You are getting here P4. So P4 is 9. P4 is 9. After that P1. P1 is 8. So P1 is 8. Then P3. P3 is 6. So put here 6. Now everything is done. See that. So your completion time is 8, and after that 8, 8, 18, 6, 9 and 21 and 19. In that way you have to cover the completion time. Okay. Now I am going to the next page. I think now how to put the completion time, that is very clear. So to do the next calculation of the turnaround time and waiting time, I am writing in the next page. Okay, just write down the completion time from here. How to check? Here P5 was 21, P6 was 19, after that P2 was 18, then P5, P6 already done, P2 already done, P5 already done, P4 is 9, P1 is 8, here P3 is 6. In that way we put this value, right? It is very clear. Now I am going to the next page and I am writing again so that you can check your calculation. So here it was like that. Your arrival time, process number was here, that is okay. The process number, arrival time, burst time, completion time, turnaround time, and waiting time. So 1 0 4 2 1 5 3 2 2 4 3 1, then 5 4 6 and 6 6 3. Okay, yes, this was the 0 1 2 3 4 6. It was 4 5 2 1 6 3. So your completion time was coming from here, that we did here 8 18 6 9 21 19. That is I am writing here. So that was 8 18, then 6, then 9, then 21 and 19. So turnaround time will be again the completion time minus waiting time. Completion time is this, waiting arrival time, completion time minus arrival time. So that is 8 minus 8 is 0, 18 minus 1 is 17, 6 minus 2 is 4, 9 minus 3, that is 6, 21 minus 4, that will be 17, and here 19 minus 3, that will be 19 minus 6, that is 13. So here total will be your 65, and waiting time, turnaround time minus burst time, 8 minus 4, that is 4, 17 minus 5, that will be 12, and here 4 minus 2, that is 2, 6 minus 1, that is 5, 17 minus 6, that is 11, 13 minus 3, that will be here 10. So that is your turnaround time, and waiting time, it will be 44. 8 17 4 6 17 13 4 12 2, 5, 11, 10. So here this is 40. So average turnaround time is 65 divided by 6, that is 10.83, and average waiting time will be 44 divided by 6, that is 7.3, right? And your task is to do the response time. What will be the response time here? What you have to check, how you have to check. To check the response time, as to check the completion time, we are going from this side. To check the response time, you have to go from this side. When when process is getting the first time chance, was 0. 0 minus arrival time. For this P2 get the chance at 2. So this one minus the arrival time. What is the arrival time? P3 getting the chance 4. 4 minus when the arrival time. In that way you have to do the response time, just like the same way how we did here, the response time. Same way, go from this side and check that first time when I am getting chance and what was my arrival time. That way you can cover the response time also. And I hope all the algorithm is very clear to you and you are watching till now. And if you are watching till now, then please let me know in the comment section that yes, your concept is totally clear or not. And this is your last minute revision, that where the starvation is going on. Starvation is there in STF, LTF, means shortest job first, longest job first, shortest remaining time first. Everywhere the starvation is there for the priority algorithm. The priority algorithm, there is starvation. Who is shortest, he will get the chance. If I am longest, I will not get the chance. That's why it is called the starvation. No starvation in round robin, because we are distributing to everyone. Everyone is getting the chance. So that's why there is no starvation. Convey effect is Fcfs. Convey means when fast come fast up. So if first time it is coming a big process and I want a very small amount of time, but because of this convoy I am not able to go. Because of this convoy, just like that when Prime Minister is coming, because of this Prime Minister convoy we are waiting in the road. If we have to go to office, then also we are not able to go. Maybe office is very less distance, that is also we are not able to go. That is called the convoy effect. Next one is the most suitable algorithm for the real time. In real time we are using the primitive priority scheduling, Primition method. And most suitable algorithm for the time sharing, that we just now saw, the round robin algorithm, that is the time sharing. And minimum average response time, when the response time is very less, it is taking as SJF, because I am taking the shortest one. So response time is minimum here. And minimum average response time for the primitive one, also the shortest remaining first time, that is the SRTF. These are very important. From here MCQ question are also coming. Remember that. And definitely share this video to all of your friends if you saw that yes, it was very helpful. And try to follow me on Unacademy platform also. I am taking the class on Unacademy platform. Unacademy platform. Here just search my name, Priyanka Chatterjee, Priyanka Chatterjee. This is my name. And you can unlock your profile. I am the teacher of UGC NET category, UGC NET set category. And you can unlock your free plan, because every day I am taking free classes there. You can unlock the free plan using my referral code PRIYANKACLIVE, Priyanka C Live. There you can unlock the free plan, because just now when I am recording the video, that is 3rd February, at that time we will do the practice on 4th February. 4th February we will do the practice on CPU scheduling, all types of numerical, all types of MCQ, previous year's question, and the future year question, that is expected question. So to do that, what you have to do, you have to unlock the free plan on Unacademy platform, install the app, register yourself, register with your name, phone number, email ID, and after that unlock the free plan using that referral code. I am giving the link also description below. 7 p.m. class will be there tomorrow. If you are watching later, then also you can watch the recording through that same link. The recording will be available, but the live class at 7 p.m. And I am taking everyday live classes. So whenever you are watching, just try to unlock your free plan and try to continue the free classes. It will be helpful to you. Thank you. Bye bye. See you soon in my next video. And if you like this video, please like, comment, subscribe, and share this video to all of your friends. Thank you. Bye bye.